So now we are from Group 5, going to present to you about Waste Incinerator. So I'm Syamim Arsyad bin Saiful, and my partner is Muhammad Zulfadhli bin Zulisam. So basically, Waste Incinerator is industrial facilities based on sustained high temperature combustion processes. The functions of waste incinerator are the first one, treat, treat hazardous clinical or municipal waste. Second, reduce its volume and hazardousness. Third, capture, concentrate, and destroy potentially harmful substances. And the last one is recover energy from the combustion of waste. So the emission factor is representative value that attempts to relate the quantity of a pollutant released to the atmosphere with an activity associated with the release of that pollutant. The general equation for emission estimation is E equals to A times with EF times with bracket 1 minus ER over 100. So E stands for emission, A stands for activity rate, EF stands for emission factor, and ER stands for overall emission reduction efficiency. So we collect four sources, which means four reference to list out every detailed data. So for the first reference, the locations data collected from the various sources. Type of fuel is solid waste, and the link amount data is not stated in the paper. Sampling system used is thermos dilution system. Efficiency is higher than 99%. Air pollution control system used are electrostatic precipitator and backhouse filter. The emission factor for this plant is 9.1 times 10 to the power of 12 part per minute. And the particulate emission of ultrafine particle equals to 5.5 times 10 to the power of 3 part per cm cube. And for the second reference, the location is Japan, type of fuel, municipal solid waste. And the loading amount is 700 ton per day at plant A. Sampling system used is Anderson stack sampler. The efficiency is higher than 99%. Air pollution control system used are back filter, wet scrubber, activated carbon tower, selective catalytic reduction. Emission factor is not stated in the paper in this paper. And the last one is particulate emission. Emission of particulate matter 2.5 equals to 0.3 to 236 microgram uh, per normal meter cube, maximum and average. So next, I will pass to Muhammad Zulfadli.
So for reference number 3, the location stated in the paper is at United Kingdom. The type of fuel is municipal solid waste, and loading amount is 52,500 tons per year at Crimliburos plant and 210,000 tons per year at Marchwood plant. The sampling system was not stated as the data was obtained from the UK Environment Agency. The efficiency was also not stated, and the air pollution control was also not stated. And the emission was not studied, as I quote unquote, was not considered to contain significant amount of particulate greater than 10 micrometer of diameter from the paper. And the particulate emission from this plant is 9.87 milligram per meter cube at maximum at Crimliburos and 10 milligram per meter cube maximum at Marshwood plant. So for reference number 4, the location stated is at Central Taiwan. Type of fuel is solid waste. Loading amount is 900 tons per day. The sampling system is dilution sampling method. Efficiency is not stated in the paper. The pollution control system is non-catalytic reduction, semi-dry lump scrubber, activated carbon injection, and backhouse filter. Emission factor is 61.6 plus minus 4.52 gram per ton waste. The particulate emission for PM 2.5 is 10.2 plus minus 0.67 milligram per normal meter cube. Based on the explanatory notes on clean air regulation from the DOE, the limit value for particulate matter is expected to be at 100 mg per meter cube for waste incinerator. Hence, by using reference number 4, we can calculate the minimum efficiency to fit the regulation. Based on the reference number 4, the info is stated as follows. Loading amount at 900 tons per day, emission factor 61.6 gram per ton waste, particulate emission at 10.2 mg per normal meter cube, volumetric flow rate at stack gas is 24.048 normal meter cube per day. So, to calculate the minimum efficiency, there are 3 steps that are required. First of all, we have to calculate the particulate emission rate, which is acquired by multiplying the emission factor with the loading amount. For the second step, we have to calculate the particulate concentration, which can be done by dividing the emission rate with the volumetric flow rate of stack gas. And finally, to calculate the minimum efficiency, we can use the formula as follows, which is particulate concentration minus the limit value over particulate concentration. The calculation will be stated as follows, and from the calculation, the efficiency that has been calculated will be at 99.99 minimum efficiency required. So that is all from us. Thank you for watching.